Hi everyone. Today I am going to explain the physics topic laser. Here we discuss many topics regarding laser. Here laser topic also includes two sections said to be as laser and optical fibers. Here we first talk about the laser. What is laser? Laser is the light amplification by stimulated emission of radiation. After we discuss what is stimulated radiation and regarding this point, we first discuss what are the properties of laser light. It is the high chance of getting the questions in the exams. Its properties of laser lights are given below. Highly coherent. It will give coherence of light, and it is monochromatic. It is made up of single type of photons, or it is made up of multiple type of photons. Also it will give the same output. Why? Because all the photons are similar. If all the photons are similar, they looks like single photon, so it will give monochromatic and highly directional light. Compared to ordinary light is not highly directional. It will diverge at some points, and it is highly intensive. And laser light is a very focusable, and it is high focusability, and it will narrow beam. Next we come to interaction of radiation with matter. Interaction of radiation matter, it includes three subtopics: induced absorption, stimulated absorption, spontaneous absorption. Here we come to know that what is induced absorption. An atom in a ground state may absorb a photon of appropriate energy and undergo transition to excited state. This is called as induced absorption. Here the representing diagram is like this. Here E2 to E1, E1 to E2 is going by absorbing the appropriate amount of energy in the form of h nu. The equation represented at E2 minus E1 equal to h nu. Next, in this topic, rate of induced absorption also comes. What is rate of induced absorption? It's easy. The number of atoms transist from E2 to E1 per second through induced absorption. It is called as rate of induced absorption. The equation of the induced absorption is R in, or you can make R induced anything else. R in equal to B1 to N1 mu of U. What is mu of nu? It is energy density of radiation. What is N1? Population of lower energy state or lower state. B12, here 1 to is the suffix 1 to 2 it is going. E1 to E2 it is going, so it is called as Einstein coefficient for induced absorption. So it is the most important equation which used in the solving the numericals, and 10 marks derivation also it will helps. And next we can come to the spontaneous emission. An atom in an excited state is unstable, hence it may undergo transition to ground level by emitting a photon. It is exactly reverse to the induced absorption, where induced absorption the atom transits from E1 to E2 by absorbing photon. Here it will, the atom will transit from E2 to E1 by emitting a photon in the form of h nu. The energy diagram is opposite to the induced absorption, and next equation will be written as E1 minus E2 equal to h nu. Here photons will be emitting. This photon is not coherent. The number of atoms from E1 to E2, The number of atoms transits from E1 to E2 per second through spontaneous emission is called as rate of spontaneous emission. Equation of rate of spontaneous emission is RSP equal to A21N2. Here we written A21 because we B21 used in another equation, so we use A21 suffix because 21 is the suffix where atom transits from E2 to E1. N2 is the population of higher energy level. Here there is no extra device or there is no extra photon which capable to do something more coherent or which enables the atom to go on transition. So here mu of population density is not there. Here incoherent photons will be emitted. Next we come to the another topic as stimulated emission. Stimulated emission: an atom in an excited state may undergo transition to ground state when a photon of light energy is made to interact with it. With emission two photons, an atom in excited state, it is exactly reverse to the induced absorption, but a photon will induces for atom for transition. Next we come to know that what is rate of stimulated emission. The number of photon transits from E2 to E1 through stimulated emission is called as rate of stimulated emission. Here the energy diagram is like this. Here two photons will be emitted. Two photons both are coherent. Next RST equation will be B21. Here we written B21. There we written A21. N2 means population of higher energy level. Mu of population density energy Einstein coefficients. B21 means. Next, it is the important derivation 8 to 10 marks question. It is relation between Einstein coefficients or Boltzmann's factor to or thermal equilibrium show that our thermal equilibrium statement is very weak. Anything they will ask regarding Boltzmann's constants or Boltzmann's constant or Einstein coefficients. The relation between the Einstein coefficients is the most common question in the question paper. Here we read the same the topics which I explained now. Stimulated emission, spontaneous emission, induced absorption, same the topic here also written, and equation can be written here. R in means B1 to N1 of mu of u, RSP means A21 N2, RST means B21 N2 of mu of u. At thermal equilibrium, rate of upward transition equal to rate of downward transition. What is upward transition? Here upward transition is the number of atom transits from E1 to E2 means it is induced absorption. Induced absorption is equal to what is down where it is a downward reaction. Downward reaction means spontaneous and stimulated emission. Here means the number of atoms transits from E2 to E1. Yeah, E2 to E1 it is same. So R in equal to RSP plus RST, where we write R in means B1 to N1 of mu of u, A21 N2 plus B21 of N2 mu of u. B1 to N1 mu of u minus B21 N2 mu of u equal to A21 N2. We take B21 N2 mu of u to LHS, make minus sign. Then mu of u should be taken as common. B1 to N1 equal minus B21 N2 equal to A21 N2. Mu of u, then mu of u is equal to A21 N2 by B1 to N1 minus B21 N2. Here B1 to N2 can be taken common. N2 denominator and N2 in numerator get cancelled. Here B12 by B21, N1 by N2 minus 1. Next, the N1 by N2 is some constant. Then B21 goes to the minus 1 side, and B21 by B12. Next, N1 by N2. We know that what we know. Boltzmann's constant means N2 by N1 equal to e power h nu by kt. Okay, but what is here we got N1 by N2. That N1 by N2 equal to e power h nu by kt. Nu means c by lambda. Then we can also write an as e power hc by lambda kt, where k is Boltzmann's constant or Boltzmann's factor. The value of Boltzmann's factor K is 1.38 into 10 to the power minus 23 joule kiloinverse. Next, with compare this equation to the black body, mu of nu equal to 8 pi h nu cube by c cube into 1 by e power h nu by kt minus 1. By comparing these two equations, we come to know that a by b. Here we take a21 by b12 means a by b. A by b is 8 pi h nu cube by c cube. Next, e power h nu cube by kt is same. Here 1 means b12 by b2, b21 by b12. Here we also conclude that b21 equal to b12. At thermal equilibrium, stimulated emission is weak because N1 is greater than N2. Stimulated emission means N2 is greater than N1. N1 is greater than N2 means it is induced absorption. So stimulated emission is weak. Next, requisites of laser system. It is also 5 marks question. First, a laser medium includes active medium. Laser system includes first active medium. What is active medium? Here, laser amplification takes place. Rate of stimulated emission predominates over rate of induced absorption. It is either solid or liquid or gas. Usually it is enclosed by optical resonant cavity, means resonant cavity is made up of mirror. Next, what is optical resonant cavity? Two mirrors M1 and M2 placed. Two mirrors M1 and M2 placed parallel to the active medium, which M1 is 100% reflective and M2 is partially 98% reflective. It is used to create large number of photons interact within. By explaining the firstly I told that made coherence. By making the coherence or monochromatic light, optical resonance should be there. So the large number of photons will interact between the two mirrors and finally at the partial they will pass through a small partial output. So it is called a laser output. Next, energy source it must be there for achieving the population inversion. We discuss a population inversion after. It is used to excite atoms to higher state. DC power supply or population inversion to be achieved. The laser system device consists M1 and M2. Here active medium, exciting source and output. Condition for user action. Condition for laser action. There is a two conditions for laser actions. Population inversion should be there and metastable state should be there. What is population inversion? Population inversion means exciting the large number of atoms to ground state to upper state or higher state, excited state, or make the atoms excited to ground state to higher state. This is called population inversion. For making the population inversion, the technique is used called as pumping. The process of exciting large number of atoms from ground state to exciting state. Next, pumping includes electrical pumping, heat, optical pumping, chemical and solar pumping, etc. Here most commonly used is electrical pumping, optical pumping. And second condition will be having metastable state. Metastable state is an excited state when atoms stay for longer period of time. Metastable state is an excited state. It differs from excited state, but where the atoms stay at long time, approximately similar to 10 to the power minus 3 seconds before they undergo transition to ground level. If their lifetime is 10 to the power minus 8 seconds, it is not metastable. It is greater than 10 to the power minus 3 seconds, it is metastable. Here we discuss about the laser topic. Here some lasers are also given, but our V2 syllabus helium neon laser is important. According to some complicative, here first laser will be discovered as ruby laser, it is a solid laser. And second helium neon laser, it is a gas laser. and it is also called as first gas laser or gives continuous output. What is principle? Gas laser consists a mixture of gases, helium and neon, in the ratio 10 is to 1. When a fast moving electron made excited to A, then A is excited. When a fast moving electron collide with A, then A is excited, represented as A star. Then A star is made collide with B, then A excited state will transfer the energy to the B, so it is called as resonant transfer of energy. This whole technique is in the form of resonant transfer of energy. We come to the construction part of the helium and neon laser. Firstly, as same as a laser, 100% reflective, 98% reflective, and quartz tube. It is a quartz tube. Quartz tube acts as the active medium where the laser amplification takes place. Here 10 is to 1 ratio gas ratio is there, which means helium and neon ratio. Helium atoms are only used to make metastable or population inversion in neon atoms. Here DC voltage is also it is a acts as energy source. Optical resonant cavity means M1 and M2 mirrors. Next come to working. Here helium excited states are F1 and F2, and neon excited states are E1, E2, E3, E4, E5. First, helium will excite to F1 and F2 by electrical pumping, discharge pumping E, and it will transfer the energy to the E5 of neon atom. It is called as resonant transfer of energy, where the E5 will emit the light or photon in the form of h nu, where the lambda will be 3.39 micrometer. It is not visible. It is for IR. Then same E5 will emit the energy in the form of h nu in the lambda. It is 632.8 nanometer. It is visible, and E3 will also emit. So it's 1.15 micrometer, not visible, near radiation. Then E4 state, it is metastable state. It will made due to NRT, due to a spontaneous emission, it will go transition to E1. By UN atoms or more, then it will be unstable, so it will returns to the ground level by due to a collision of the wall tube. Then it will same procedure happens from the helium, so it will be look like as cycle, so it is gives continuous output in the form of gas laser. Advantages: producing 3D updates, reading barcodes in supermarkets, optical communication, ophthalmology, printers, optical instruments, etc. We know that helium neon laser we not seen means if you visit the supermarkets, the barcode scanner is there. In the barcode scanner, the laser is also there. This laser is called as a helium neon laser as gas laser. Barcode scanners. Barcode consists series of adjacent and black white spaces. A barcode reader is an electronic and robust electronic device which is used to read the printed barcode pattern. In barcode, we observe that adjacent white and black spaces are there. When the barcode reader is held on the barcode, then the black lines or black spaces will absorb the light and they will read the data or information from the lights and send back from the white spaces. White spaces send the data in the display by the user. Advantages is accurate, no human error, labor free and time saving, etc. Laser printer. Laser printer is used to get the high quality images or 3D printings at home easily. By using laser technology, we make higher images on test on the paper. Laser beam is used to scan the receptor technique, or it will be drum is there where the drum rolls, then the pattern will be prints on the text paper.